Hi, good morning everyone. Thanks for joining again. I wanted to do this video on the topic of modeling interfaces, and this specifically will be geared toward modeling physical interfaces with Cameo Systems Modeler. And I know there's always a lot of different opinions out there for how interfaces can be modeled. And this is not to say this is the only way you can do this, but I wanted to offer this as an idea and as a method that you could consider for modeling physical interfaces when you get down to things such as physical connectors where they're connecting to other parts of your system and how you can show that in Cameo Systems Modeler, as well as attach requirements to those different aspects of the interface. So what you're looking at here is a simple architecture. So we have a system, and that system actually has three parts. As you notice, we have a cable, an actuator, and subsystem B. So what this will do is essentially dive into how these two interfaces actually connect, and then how can we show that what's on one side of the interface is getting what it is needing from the other interface. What I'll do is delve into the IBD, or the internal block diagram, to show the method for how I'm connecting these two parts. But before we do that, notice we have a proxy port here. The proxy port is named interface 2 or IF2, typed by actuator interface. And that actuator interface is this interface block. So the neat thing with interface blocks is they can type a proxy port, but then they can also have reference properties. So if you notice, if you go to your options to add properties to an interface block, you can add flow properties to those. Those are great for doing logical flows. And then also you can add reference properties. And the nice thing about reference properties is they can be typed by blocks. So here we have a reference property that is named electrical connector, and it's typed by this other block that further defines what that is. So it's typed by 21-pin connector male, which is this block here. And then if you notice, that block also has reference properties, which can then be typed by other blocks. So in this case, we have a pin, and the name of that reference property is pin 1 typed by electrical ground, which is this block here. And then we have pin 2, which is typed by 12-volt VDC, which is this block here. And you can see how you could continue down that path of further defining things to the level that you need to. And the same thing goes for the other side of that interface, where we have the sub B interface. It has a reference property called electrical connector, which is the same name as the other side of that interface. But notice it's typed by 21-pin connector female, which is this block here. It has the same thing. It has a pin 1 and a pin 2 typed by the same blocks. Notice, however, we've also added a direction to these features. So these are considered features, and then we can set the feature as a provided or required interface, or you could do provided and required. So in the case of the ground, we're setting that to provided and required. And then for the case of pin 2, we show that this female connector is actually providing that 12-volt direct current. So then let's dive into how we actually connect this in the internal block diagram. So we've created the internal block diagram. We have subsystem B connecting to the actuator, and then these originally were full ports that I refactored to proxy ports, which is why they're still showing in this color. However, these are our proxy ports here. This is one here, this is one here. Typically in logical ICDs, you'll simply connect a port to another port. But in this case, I'm actually connecting reference properties to other reference properties. And that's very intentional. The reason for doing that is that we can then query off of this connector. So these lines here are considered connectors, and you can build a query that we'll look at in a moment that actually follows one direction with one part of that query, and then follows the other direction with the other part of that query. And what's very interesting about connectors is if you look at their meta model, they actually have two ends. So this connector has an end here and an end here. And if you were to simply create an out-of-the-box Whitebox ICD that Cameo has available, what they do is they bury some of the script that actually parses out each side of this, which creates one column that shows one side of that and another column that shows what's in the other side of that. So if you were to try to recreate that on your own in a generic table, what you would find is that if you simply query that connector and then the ends, you'll get both ends in one column, and you don't get that mirrored side of that, so to speak, to see what connects to what. You'll actually have both results in one column, which is not typically what you'd like to see in a Whitebox ICD. So what we can do is then delve in, use a little bit of customization such as this, and actually parse out each connector end. So let's delve into how we can parse that out. And then after we do that, what you'll end up with is a table that looks something like this, which is a generic table. However, it's been customized so that you can then take your meta chains even further to show requirements that are associated with these different parts of each side of that connector. So that's how this gets very interesting. So let's delve into that for a minute and show how we build these meta chains that actually go in either direction based off of those connectors. So the big part of this is how we parse out each of those connector ends. So this is a customization. It's the same thing as a derived property. You could create this in the table simply by creating a new derived property, but I've created it here as a customization. Notice it's a customization of the connector meta class. So this will actually add a property to the connector that you can then view and actually meta chain off of. So for this connector and a custom, we'll delve into this. And this is using an OCL script. And notice we have OCL2, that's the language here. And then the script is simply self.end sorted by ID at 1. And this one part of this is the important part, because the first side of a connector that you connect something to actually is considered side 1, whereas if you were to connect that to something else, that would then be considered side 2. In a Whitebox ICD table, they call that side A and side B, but the actual script that parses this out numbers that as connector end at 1, and then you have the other side of that that is assigned the value of 2. So let's expand this for a moment and notice this is simply set to this. So it'll be this connector, whichever connector we're looking at, it will sort by ID 1. And then we've named that connector and a custom. And then the neat thing about that is then we can then meta chain off of that. So notice in connector NB custom, you'll see the exact same script. However, that is the one that is at side 2. So that would be the one that you connect your connector to. And then once you've created those two derived properties, you can then query off of those derived properties in other derived properties, which is what we're doing here. So notice you have connector and a role. And if we look at the meta chain for this, notice it's a meta chain navigation now. However, it starts with the connector, and then it goes to connector and a custom. So that's that OCL script as part of a meta chain now that we're now taking one step further by looking at that connector end and then its role. And that will produce one of the columns in your custom Whitebox ICD table. So connector and a role would then produce this data here. So we have, notice the reference properties that are considered the role at that point, and we show their names and their type. But then how do we get over here to where we have requirements actually associated with those? Let's look at the meta chains for that. So we've named this interface side A requirements. So we can delve into this meta chain. And notice we're starting with that connector and a role now, which was that derived property that actually meta chained off of the initial derived property. And now we're taking this a few steps further to then look at connector and a role, the reference property that it is that you saw in the table, and then its client dependency, and then the satisfy relationship and the supplier of that satisfy relationship. So that's how we end up getting to the requirements. And then if we look back at the block definition diagram, if we wanted to add in another requirement, let's say for the electrical ground, what we can do now is simply use a satisfy relationship from that reference property and go down to our requirement for that, and then that will be pulled into the table. So notice nothing has changed yet. However, if we refresh this table, what you notice is that we have now pulled in that requirement, and it simply shows up in this column here. And you can do the same thing on the flip side of that. So one of the huge benefits to this is where we can show requirements for the case of this specifically. We could say that this pin requires 5 amps. And this here shows that the other side that it connects to provides that 5 amps. So that would be a great way to match up what is required on one side of the interface to what is actually being provided on the other side of that interface. And then if you notice, we have a few other things here, such as the mechanical. So we have an actuator interface that has an electrical connector, but then it shows a mechanical drawing as well that is typed by this actuator interface mechanical block. That is something that you could attach a file to if you wanted to actually show the drawing and have that incorporated into your model. So notice in the containment tree, we have actuator interface mechanical. If you had a PDF drawing or some other type of drawing, you could create an element here and then go to attached file. And when you go to attached file, you can simply browse for that file and attach that to your model. And then you'd have that data associated with this block that we've called the interface mechanical. Of course, you could always digitally thread this part of your model to a CAD model. So that is the other advantage of having a block in your SysML model that references that CAD model, because you can pull that in as a digital thread and actually not have that data living in your SysML model, but simply digitally threaded to that in another repository. And you can do that with tools such as Sendea, which are great for a synchronization middleware that actually links Cameo Systems Modeler to other tools. So I hope this has been helpful. If you have questions on this, please feel free to reach out. Again, this is specifically for modeling down to the pin levels of things such as physical interfaces. This is not typically how you would model your logical interfaces. Logical interfaces, a lot of times you would simply show with that proxy port connected to a proxy port. If your project is in need of model-based systems engineering expertise, please feel free to reach out to STC and we'll be happy to help out your team. Thanks for watching. I hope this has been helpful. Thanks.